All right, so for u substitution, typically we're letting u be the input of the composite function. So I'm going to try that here and see if it works. Most of the time it works out nicely. Sometimes, like I think in this example, we'll have to do a little more work. Du is just 2dx. dx would be du over 2. So we do our substitution, change of variables. I haven't subbed out x. This is the square root of u, which I'll just go ahead and write as u to the 1/2, which we like to do. And then I'll sub out my dx, which we solved for, and I get du over 2. And I'm going to go ahead and factor out the constants, 5/2. And I get x u to the 1/2. But I got a problem, right? Because a lot of times when we do these, there's an x down here, and the x's cancel out, right? Or if you're looking at u prime times composite function u. That didn't happen in this case, but what we do with these is we go back to our relationship between x and u, and we try and solve for x. So let's see what happens when we do that. I'll subtract 3 from both sides. And then I'm going to go ahead and divide by 2. And I get a statement for x. X is u minus 3 over 2. So let's try that. Okay, now this should allow me to integrate. So I'm going to factor out the 1/2, so I get 5/4. And then, so that got factored out. And then I'll go ahead and run this guy through. So u to the 1/2 times u is u to the 3/2. And then minus 3u to the 1/2. And now I'm able to integrate. So I get 5/4 times u to the 5/2 divided by 5/2, or times 2/5. Minus 3u to the 3/2 divided by 3/2, or times 2/3. Squeeze that in, I just get a 2 there. And plus c. So my final answer would be a 5/4 times 2/5 u, which is 2x plus 3, to the 5/2, minus 2 u to the 3/2 plus c. Okay, so this is one of those cases we see every once in a while where when you do the substitution, you still have an x hanging out in there. So then you got to go back to this relationship and see if you can sub it out.